All right, so we're going to continue with section 13.1, and I'm going to briefly talk about what's called a level curve. So given a function z equals f of xy, and a real number c, the set of points xy in the xy plane that satisfy f of xy equals c is a level curve. And that'll be more clear once we look at an example. Visually, a level curve of f at c is the trace z equals c projected into the xy plane. So it's like if you took that trace x equals z equals c, excuse me. So you pick some value c, you took your graph and you slice through your graph at that value c, whatever that slice looked like, you would just take that slice and you would draw it in the xy plane. So places that you all would have seen level curves is, say, on a map that shows elevation. There's no way to actually depict that the three-dimensional region in a two-dimensional map. So instead, what they would draw are level curves, which show the elevation at any particular point. Or you might see it like on a temperature map that shows the different temperatures at different, or it really doesn't show it at any particular point. It picks a temperature, say whatever, 75 degrees, and then it'll set whatever the surface function is equal to 75, and then draw that curve. So slice through whatever, say you had some mountainous range and you slice through there at an elevation of 50 feet. Then if you would, on the map, you would sketch that slice, that curve of that slice, and you would put a number 50 there to represent that the elevation is 50 there, or temperature, whatever it is that you're talking about. So we'll do a couple of examples of level curves so you get an idea of what they look like. So we're going to start with number 17 on page 823. So page 823, number 17 says, in exercises 13 through 18, sketch the level curve f of xy equals c, and they give us f of xy equals x squared minus y squared, and they tell us to sketch this for c equals -1, c equals 0, and c equals 1. So c equals -1, 0, and 1. So we're gonna, now with the level curves, notice level curves, you're always changing your z to those values. So traces, you could change any one of those to some constant c, but level curves, you're always changing your z. So first, let's rewrite this as z equals x squared minus y squared. And then another thing with level curves is you sketch all of these in the same plane, because level curves are always sketched in the actual xy plane, whereas traces aren't truly in one of the coordinate planes, the XY plane or the YZ plane or the XZ plane. So first, let's just look at the level curve. We'll determine what each one of these three level curves looks like, and then we'll sketch them all in the same set of coordinate axes, or we'll sketch them one by one, but I'll put them all in the same coordinate axes. So first, let's look at the level curve. C equals -1, but C equals -1 means that Z equals -1, which means this equals -1. So you can write whichever way you want to. You can write C equals -1, you can write Z equals -1, you can write that equals -1. Really, we're going to end up looking at this equals -1. So let's call it the level curve because of the way that we defined it. Let's call it, we'll just say f of xy equals C. So the level curve will be -1 equals x squared minus y squared. Now we have to figure out what this thing looks like, and you can use your prior knowledge of conic sections. You can go on Desmos, DESMOS, and plot this to see what it looks like. It doesn't matter how you go about doing it. So this is the same as 1 equals y squared minus x squared. And if you don't remember conic sections, those are in your textbook somewhere as well. It's not in the calculus 3 sections though, but they are. The conic sections are in there. You can just look up conic sections in the back of the book. This is a hyperbola. So conic sections are from 2 dimensions. We're going to talk about what are called quadric surfaces, which is like the analog to a conic section, but in 3 dimensions. So this is going to be a hyperbola, and let's sketch this. And we're going to make our sketch fairly large so we can see, but I'm going to leave some space so we can do the work for our remaining level curves. So. All right. So we're never going to sketch that the Z is equal to -1. That will be below the XY plane. What we're going to do is we're going to take that sketch and we're going to shift it up to the XY plane. We're going to take this one, which isn't in the XY plane. We're going to, of course, just put that in the XY plane. And this one we'll leave that in the XY plane. This one's above the XY plane. We're going to take it and we're going to shift it down to put it in the XY plane. So now we're sketching this hyperbola, which is going to look something like, actually, you know what, I'm going to draw that. I'm going to do these first because it's going to help me sketch that one anyway. So let's do our level curve for 0, and then I'll sketch all 3 of them. Make my life a little bit easier. So here we take 0 equals x squared minus y squared. And this is going to give us x squared equals y squared. And then we solve that and we get x equals, or I should do y equals, let's do some as well. That's what we're more accustomed to. Y equals plus or minus x. All right, so that one is going to be just 2 lines, those diagonals, and that's going to help me make sure I don't go off course with my hyperbola. That's why I want to sketch that one first. So it's probably wise anyway to write down what all your level curves are before you start sketching. Otherwise, you may end up running into one another when you make your picture, which they should not run into one another because they're all different values of Z. So they shouldn't be running into one another unless you had something that was, say, for instance, like a cylinder. And in that scenario, you don't have any Z to put in. Your Z stuck at being constant. So your level curves for that would look all the same, but you can't Well, actually, I guess you can't really define those as level curves because you don't have any z there in the first place. So scrap what I said. So level curve was our 1. So now we had, what are we doing? 1 equals x squared minus y squared. All right, so now that we have all of those, we'll go ahead and we'll sketch them on here. So I'm going to start and sketch this one first. Now somewhere in your sketch, you're going to leave a little opening so you can sketch what it is that, so you can write down what it is that you were sketching there. So here, I'm going to leave mine right here. And this is for c equals 0. And that's what you're going to put, c equals 0. And then you can continue it right after that. Now, this other line over here is also for c equals 0. So if you want to label that one with c equals 0 as well, you can. I'm not going to because I'm already going to overlap with some of my other pictures with that. So both of those are from c equals 0. Now, let's look at c equals, let's look at this one, the c equals -1, which is the very first one we did. All right, so in order to, once again, you can put this in some online tool and sketch it, graphing calculator, whatever you want to do, but just to figure out from what we have here, what it would look like. So let's look at, see if we tried to do y equals 0, what we get. If we did y equals 0, we would get that negative x squared equals 1. So we know that y can never be 0 because it's impossible for negative x squared to be equal to positive 1. On the other hand, if we look at x equals 0, then we get y equals plus or minus 1. So for x equals 0, we're going to have y equals positive 1 and negative 1. And then from there, we know that it's going to be hyperbola, and we'll use these lines right here, which are the actual lines that are going to be our asymptotes. So it looks something like this. And remember, we're doing a rough sketch, so don't worry too much about how your sketch looks. Now, I forgot to leave some space to stick in my c equals -1, so I'm going to have to do it up here. So let me just do this. C equals -1. All right. And then now we're looking at this one down here, which is also going to be a hyperbola. So you put in y equals 0, you'll get x equals plus or minus 1. So if you remember like sketching conic sections when you did a hyperbola, like you would make this box, but you don't have to do all of that stuff. Please don't worry about all of that because this is not our focus point is sketching conic sections. So this is for c equals 1. So I'll put that over here. And those will be those 3 level curves that they requested of us for this particular problem. All right, so we'll look at one more of those, and then we'll switch gears and we'll start looking at quadric surfaces. So let's look at number 18. So we're still on page 823, looking at number 18, and same directions. So they give us, and I'm just going to jump to writing this as z. They give it to us as f of xy, and that's the same as z equals 2y minus cosine of x. And they tell us they want us to sketch the level curves for z equals 0, 1, and 2. So first we'll just figure out what the curves are, and then we'll sketch them all together. So level curve for, in this time, you can write it as z equals 0. You can do it the same way I did it before, where you just plug in 0 for z. 0 equals 2y minus cosine of x. And then we want this in a more familiar form, so we'll solve this for y. So that's 2y equals cosine of x, or y equals, excuse me, 1/2 cosine of x. Then, sorry, I'm losing my voice. Sounds like the next level curve is 1 equals 2y minus cosine of x. Sorry about that. I want to leave space for my graph. So here, if we solve for this, we get 1 plus cosine of x. So we get y equals 1/2 plus 1/2 cosine of x. So the nice thing about it is it's that same thing that we have there, but now it's shifted up 1/2. So we don't have to do anything fancy to draw between those different graphs. So just like in our last one, we had 2 hyperbolas. So level curve. The last one we have is 2. So if we do 2 equals 2y minus cosine of x, then that is going to give us y equals 1 plus 1/2 cosine of x. So now sketching these level curves. I should actually move my axis over. So c equals 0. Let's do c equals 0, c equals 1. So remember, for c equals 0, this our amplitude of cosine of x is just changed to 1/2 instead of 1. So it would look like that. Come back this way. I'm just going to put my label at the end over there. Oops, that was supposed to come up. Now for, and this is 1/2 right here. Sorry, that's 1/2. And then for c equals 1, we just take this graph and we shift it up 1/2 unit, excuse me. So we would have that, oops, it wasn't supposed to. So that's what that should look like. And this is for c equals 1, and that would be at 1 right there. And then lastly, we take this and shift it up 1/2. Oops, my graphs are getting kind of squished. Sorry about that. And this one is wrong entirely. I should have left myself more space. It should come down here, but they should not be getting skinnier and skinnier, although they are getting skinnier and skinnier. So I apologize for that and scrap that part right there. This is 3/2. And that one we'll label over here is c equals 2. And those will be our level curves there. They should have all looked exactly like that and just been shifted instead of getting more and more narrow. All right, so we'll stop this video there, and then our next video we'll start looking at quadratic surfaces where we sketch things like that paraboloid that we sketched previously.